Hi, welcome to AB Video 1.4a Part 2, more on continuity.
Ask you to answer 3 questions, and those 3 questions are, at this point in time, they're not talking continuity, they're just talking about limits. So they're going to actually ask you what's the limit from the right, or what's the limit from the left, so those are the two one-sided limits, and then what's the two-sided limit. So if you're looking at the picture, the limit as x approaches negative 2 from the right. I always find it strange they ask it for the right first. You can see that that approaches a height of negative 2. Also, they're not very imaginative. Really, they had to have the same x and y intercepts. The limit as x approaches 2 from the left, which is what that little minus means. If you're on a bug on this curve and you're approaching x equals negative 2 from the left side, you will also be approaching a height of negative 2. The decision you make, and this is crucial, the decision you make as to what the limit as x approaches negative 2 from both sides is, don't even bother looking at the graph. You don't need to. As long as the two one-sided limits equal the same number, which in this case they do, then that's what your two-sided limit is. You do not need to look at the actual graph to get that answer. Now, I do want to talk about the fact that your book is going to ask you to find those 3 limits from the right, from the left, and the two-sided. Use the graph to determine the limit. But then they say this very bizarre statement, discuss the continuity. Excuse me. That's very vague. Lord knows what they mean by discuss, so I'm not going to ask you to discuss. I don't know, maybe you'd want to discuss that you don't like them very much. So, what I'm going to ask you is the function continuous at x equals negative 2? So that comes back to our trilogy where the c we were talking about is negative 2. So remember, the questions are, is f of negative 2, remember to start with that one, make sure you don't put an x here, and the negative 2 comes from here. Is that equal to the limit as x approaches negative 2 from the left of f of x? And is that equal to the limit as x approaches negative 2 from the right of f of x? Okay, so all 3 of these have to exist, which means they can't equal infinity or negative infinity or be undefined. And they all have to equal one another. This box, this blue box, is the key thing I need to see. This shows me that you understand what it means to be, for a function to be continuous at a number. So we're going to look at the graph, f of negative 2, which they didn't ask up here. F of negative 2, there's an actual filled in dot there. As you can see, f of negative 2 is negative 2. And then, of course, the two-sided limits we just found up there. Part A asked for this. We came up with negative 2. Part B asked for that. Turns out all 3 expressions are equal to one another, and they're all real numbers. We can therefore conclude that the function is indeed continuous at x equals negative 2. Okay, so here's another example. They're going to ask for the two one-sided limits, and then they're going to ask for the two-sided limit. The limit as x approaches negative 3 from the right side, so you're on the curve approaching negative 3 from the right side. The height that you reach is almost a height of 3. So that limit is equal to 3. The limit as x approaches 3 from the left side, again approaches a height of 3. And therefore, without even looking at the graph, you can see that the two-sided limit is 3 simply by looking at your answers for parts A and B. They're the same number, so that's what the two-sided limit equals. Again, my question will not be discuss the continuity. My question will be, is f continuous at x equals negative 3, and justify. So we're back to the trilogy where our c this time is negative 3. So is f of negative 3 equal to the limit as x approaches negative 3 from the left of f of x? You have to have an f of x here. Is that also equal to the limit as x approaches negative 3 from the right of f of x? So, the only one that we hadn't looked at so far, I don't know why it keeps doing that, was the f of negative 3, because this is question B, which we answered, and this was question A that we answered. So if we go back to the graph, and we look at what is f of negative 3, as you can see, the filled-in dot is at negative 3, 4. So f of negative 3 is 4. So we come down here, and of course the two one-sided limits were both 3. So what we have is the question, is 4 equal to 3 equal to 3? Of course the answer is no, it is not. And therefore this function is not continuous at x equals negative 3. Another way of saying it is to say that f of x is discontinuous at x equals negative 3. Number 6 is your graph. What's the limit as x approaches negative 1 from the right? So I'm on the graph on the right side of x equals negative 1. I'm getting closer and closer to negative 1. You can see I'm approaching a height of 0. The next question is, what is the limit as x approaches negative 1 from the left of f of x? So now I go back to the graph. I'm approaching x equals negative 1 from the left side. You can see I'm approaching a height of 2. So that one is 2. The third question is, what is the limit as x approaches negative 1 from both sides? Again, you do not need to look at the graph anymore. All you need to do is look at the left-sided limit and the right-sided limit. They are not the same. Therefore, the two-sided limit does not exist. And that's why I keep putting these arrows here. Next question. Is f of x continuous at x equals negative 1 and justifying? So again, in order to decide that, we need the trilogy. Is f of negative 1 equal to the limit as x approaches negative 1 from the right of f of x? And is that equal to the limit as x approaches negative 1 from the left? Now these two answers we got, negative 1 from the right was 0, negative 1 from the left. Negative 1 from the right was 0, negative limit as x approaches negative 1 from the left was 2. The third piece of that trilogy is, what is f of negative 1? Well, f of negative 1 is a filled in dot. It is 0. So we end up with, is 0 equal to 0 equal to 2? Again, the answer is no, because they're not all the same. Therefore, f is not continuous at x equals negative.
And that's the end of video 1.4a, part 2.